Welcome to the Deep Dive. Today we're tearing into a stack of source material you shared with us, and it details a pretty major shift in the world of software automation.
Yeah, a big one.
We're focusing specifically on that high-stakes, repetitive work that, happens inside the browser, and we're going to examine a key new technology provider here, Pendless. So for anyone listening who has ever tried to automate a multi-step workflow, this core problem is going to be immediately familiar.
Oh, absolutely.
Automation promises to make your life simpler, but what it often delivers is just frustrating brittleness.
Right. It breaks all the time.
We've all been there, right? That expensive legacy RPA script breaks the second the website UI shifts just a tiny bit.
Or your API tool just stops cold.
It stops cold because it hits a login portal that needs multi-factor authentication. Or, worst of all, you use one of these new, exciting agentic AI browsers.
And you just watch it wander.
You watch it scroll wildly, guessing correctly, and then it ultimately fails the task because the interface confuses it.
It gets lost.
So our mission for this deep dive is to take these sources and uncover how this new, distinct category AI browser automation claims to fix these really pervasive problems. Is it genuinely a path to robust, repeatable automation?
Or is it just more of the same?
Exactly. Is this just the latest iteration of the same old problem?
And that frustration is really the through line of automation Maori, isn't it? We've always been chasing this perfect balance between power and reliability.
And we usually fail on reliability.
We usually fail on reliability. We started with, simple workflows, then moved into this heavy infrastructure of robotic process automation.
RPA.
And now we've embraced the flexibility of agentic AI. Pendless is claiming that frontier position. They're arguing they've merged the high precision needed for enterprise-grade RPA.
The kind that absolutely cannot fail.
The kind that can't fail with the intelligence of modern AI. And the key claim is that they deliver this directly in the browser, instantly.
Without the code.
Without the code or the huge infrastructure build-out.
So reliability without the headache. It sounds like a pitch we've heard before, but the sources do make a strong case for why this is different. Let's start by mapping the competitive landscape. If we want to understand where Pendless fits, we first need to define the 5 distinct categories that are all vying for automation supremacy right now.
Okay, let's lay it out.
All right, so category 1 is what we call business process automation, or BPA.
Right.
These are highly specialized tools. They're designed to solve one specific workflow, often vertically. So think dedicated platforms for automated invoicing or KYC checks in finance.
And the limitation there is pretty obvious. It's the specialization.
Right.
If you want to automate a process that spans 3 different apps, or you need to pull data from some legacy portal that your tool wasn't built for, you just hit a wall.
It's powerful, but only in its own little lane.
Exactly.
Which leads us directly to category 2, workflow automation platform.
Ah, the connectors.
These are the ones everyone knows. Zapier, Make, and their peers. They're fantastic at connecting different apps using APIs.
But there is a critical choke point for those tools.
Which is?
They only work if the API exists and is actually exposed. The moment a critical piece of that workflow requires you to log into an old insurance system.
Or a government portal.
A government portal, or even just a SaaS product that hasn't published its latest API endpoints, the platform just stops. It's stuck outside the browser walls.
Which is exactly why big enterprises turn to category 3, the real heavy hitter. Robotic process automation, or RPA.
UiPath, automation, anywhere.
The big guns. These tools automate legacy software by literally controlling the user interface, the mouse, the keyboard, the clicks.
Yeah.
Now, the sources describe RPA as powerful but prohibitively brittle, expensive, and slow to implement. So why would an enterprise abandon that heavy, established infrastructure? What's the real technical cost of that legacy approach?
The technical cost is, in a word, rigidity. Legacy RPA relies on recording fixed coordinates or very specific visual selectors.
Okay.
It's like giving a robot step-by-step driving directions based on static landmarks.
So if a website's design team shifts one button 2 pixels to the left,
the script breaks, and an expensive developer needs to be called in to fix it. The sources rightly call this infrastructure.
It really is.
It requires a dedicated team, multi-week setup, constant maintenance. It's just a massive sunk cost.
That brings us to category 4, the wave of the future, agentic AI tools.
Right.
These are the new AI browsers and assistants, Comet, Atlas, or even the computer use functions built into large models like Claude and Gemini.
You give it a goal in natural language.
And it tries to figure out the steps on its own.
They are flexible, for sure, but they rely on this intensive, sometimes very slow AI inference to look at the screen and decide what to do next.
So they're more for exploration.
Exactly. They're often built for exploratory assistance, figuring out a complex task for the first time. And that flexibility comes at the cost of the repeatability you need for enterprise operations. They wonder.
And finally, that brings us to Category 5, AI browser automation. This is the new category where Pendless is positioned. It combines dynamic page understanding, natural language instruction, and, crucially, repeatable execution without all that brittle code or the heavy inference costs of the agents.
And what's really fascinating here is the philosophical departure. They're trying to be the opposite of legacy RPA.
How so?
Instead of requiring developers and infrastructure, Pendless aims to be a precision tool built for the cloud era that, operations teams can deploy instantly. It relies on real-time page analysis, not static code.
So it's all about operational speed and resilience.
Above all else.
That resilience is key. I mean, if most automation tools break when the interface changes or they hit a login, they aren't actually solving the core business problem of reliability.
Not at all.
So let's drill down on these comparisons and the specific pain points they're targeting. First, let's contrast it with legacy RPA. We established that those scripts break easily because they're rigid. Pendless, on the other hand, dynamically reanalyzes the page on the fly.
So if the website changes,
Pendless reanalyzes and just adapts its next action. The pros listed in the sources are huge. Near zero setup costs, rapid deployment, and that resilience.
it's a big deal.
However, there is one major limitation we have to address head-on. The sources note that Pendless is currently browser-only. It doesn't automate desktop applications. Isn't that a pretty significant trade-off compared to a full RPA suite like UiPath?
It is a trade-off, definitely, but the sources imply it's a calculated one. It's based on where the majority of operational friction actually is today.
Which is in the browser.
Which is in the browser. If 90% of new business workflows, whether it's CRM updates, claims processing, compliance checks, if they all live inside a web browser, then focusing exclusively on perfecting that last mile of browser automation, it makes strategic sense.
So they're sacrificing desktop versatility for browser perfection.
Browser perfection.
Yeah.
And that perfection is essential when we compare them to API-based automation like Zapier or Make.
Right.
The difference is stark because Pendless operates exactly where those API tools fail.
At the login.
At the login. Those platforms stop the second they encounter a login portal, MFA, or a legacy UI that hides its endpoints. Pendless works directly in the real browser session, handling those complex real-world systems.
Insurance portals, old HR systems.
Government sites. It closes that last-mile gap that APIs just cannot touch.
So it's automating the work people actually hate doing.
Precisely.
The repetitive, authentication-heavy data movement tasks that require a human to sit there and just click through a terrible interface.
That's the stuff. And if we look at visual RPA tools like Axiom.ai, which are often sold as the no-code solution,
Right.
they still rely on visual blocks, logic building, and manual step sequencing. You still have to build a brittle workflow block by block.
You're still the builder.
You're still the builder. Pendless's approach removes the builder entirely. You just instruct it in natural language, and its dynamic analysis figures out the execution path for resilience. It's about removing human friction from the creation process as well as the execution.
Okay, and finally, let's talk consistency. Headless bots and traditional web scrapers are fast, but they struggle with dynamic pages, with authentication flows.
And just replicating real user interaction.
So why is operating in a real browser so critical for business operations compared to just scraping the server calls?
Because consistency is paramount for operations. Headless bots and scrapers often emulate server calls, and when back-end server logic shifts or a page requires JavaScript to render properly,
Like break.
they break. Pendless operates a genuine full browser session. It's behaving exactly like a human employee, ensuring it can handle complex interactions, and crucially, making the outcome repeatable and auditable for high-stakes business functions.
So it shifts automation from being an unstable script
To a reliable operation.
This is where we move from architectural theory to concrete proof.
Yes.
The sources include a detailed head-to-head benchmark that tested these reliability claims against a major competitor in the agentic AI browser space, Perplexity's Comet browser agent.
And this was conducted in November of 2025.
Right.
And benchmarks like this are really the only way to validate these kinds of claims, and the setup was rigorous. They ran 34 standardized prompts representing common business workflows.
Things like
Multi-step form completion, data extraction followed by injection into a second system, and complex navigation logic. And they were running on the exact same complex websites under the exact same conditions.
And they measured 4 key metrics that really define operational success. Let's define them clearly before we get to the numbers.
Good idea.
We had precision, which is the percentage of attempted actions that were executed correctly. This is vital because it stops misclicks and data errors.
Then there was recall. That's the percentage of all required workflow steps successfully executed. This ensures you complete the end-to-end task, not just half of it.
Right. If you have low recall, you generate operational drag.
Yeah.
A human has to step in and clean up the mess.
Every time.
Third, execution time pure speed from start to finish. This directly impacts how much throughput you can achieve and, your ROI.
And fourth, general errors. So workflow blocking failures, agent crashes, or just navigation breakdowns.
Okay, let's get to the speed first. Pendless clocked in averaging 23.4 seconds per prompt.
And Comet.
Comet averaged 2 minutes and 13 seconds.
Wow.
Pendless was 480% faster.
480%.
That speed difference is staggering, especially against a leading AI agent. I have to play devil's advocate here.
Yeah.
Could that difference be explained simply by Pendless skipping some complex verification steps or taking shortcuts?
That's a fair challenge.
I mean, how do the sources ensure the comparison was truly apples to apples on complexity?
The structure of the 34 prompts was designed specifically to require multi-step sequential logic. So skipping steps would have meant an instant failure, which would have just destroyed the recall score.
Okay.
The speed difference seems to be structural. It's rooted in those architectural decisions we talked about earlier, while Comet is using heavy AI inference to reason about the page.
To think about it.
Pendless is using its lightweight engine to simply execute based on the page's structure. That eliminates the agonizing lag time of the AI agent deciding which button to click next.
But speed only matters if you're accurate.
Absolutely. So for precision, the avoidance of misclicks and bad data Pendless achieved 97.2% compared to Comet's 93.3%.
And while 93.3 sounds high,
in enterprise operations, that 4% difference is the difference between data integrity and expensive manual cleanup. It's huge.
and that precision extended to completion, right? In terms of recall finishing the job, end-to-end Pendless hit 97.9% versus Comet's 93.6%. I mean, think about the compounding effect of that 97.9% recall. It almost eliminates the need for human intervention.
Right. If you run 100 tasks, Comet fails 5 or 6 times, requiring someone to go in and fix it manually.
And that leads to the final killer metric, general errors.
Okay.
Comet recorded 6 workflow blocking failures across those 34 standardized tasks. Pendless recorded 0 failures.
0.
0. That level of stability is the true operational game changer, especially when you're deploying automation at scale where system failures are just unacceptable.
Absolutely.
0 failures and 480% faster execution. We have to dive deeper into the technical architecture that explains this massive performance gap.
Yeah, let's get into it.
We have to move beyond just the concept of dynamic analysis.
Absolutely. The explanation really lies in the execution engine. Agentic systems, like the computer use versions of Claude or Gemini, they rely on these heavy, large visual reasoning models.
So they're looking at a picture.
They're essentially looking at a picture of the screen, scrolling, guessing, and often getting confused by dynamic elements or pop-ups. This is why they are so slow and why they occasionally hallucinate the next action.
I see.
Pendless, conversely, uses a lightweight, DOM-aware execution engine. The Document Object Model, or DOM, is the underlying blueprint, the structural code of the web page.
The skeleton.
The skeleton. It's optimized specifically for browser tasks, allowing it to use deterministic action planning that aligns with the real page structure.
So, if I understand this correctly, it's not trying to look at a picture of the screen and guess where the button is based on visual cues.
No.
It knows the structure of the page and where that button lives in the hierarchy.
Exactly. It uses the website's internal blueprint rather than its appearance to decide where to act. This fundamentally reduces those hallucination pathways.
So its whole posture is one of robotic consistency.
Yes, designed for predictable, repeatable action sequences, which is exactly what operations teams need. It's built to click the right button the first time, every time.
That structural reliance raises an interesting question, though. Does that mean it fundamentally can't handle situations where the required data isn't exposed in the DOM. Is that a non-issue in the type of apps it targets?
That's a great question. In the vast majority of standard business applications, if a human can see and interact with an element on the screen, it has to be represented in the DOM.
Okay, so it's a non-issue for the most part.
For the most part, yes. This architecture capitalizes on that fact. It's designed to automate real-world clicks, forms, data transfers, all of which rely on accessible page elements. Now, if the task is purely visual or requires complex human-level reasoning about ambiguous data,
The job of an exploratory AI agent.
that's where it steps back. But for high-volume, repetitive business processes, DOM awareness is just superior for reliability.
So what does this all mean for the bottom line? The speed and accuracy, they compound in practice.
They absolutely do.
Faster agents reduce queue backlogs, they maximize throughput, higher precision protects data integrity, and reduces compliance risk.
And fewer errors mean your team spends less time on manual cleanup and fire drills, freeing them up for higher value work.
Right. The sources summarize the two categories perfectly. AI browsers like Comet represent the evolution of browsing. They're flexible, exploratory assistants. Pendless represents the evolution of automation. It's a precision robot built explicitly for enterprise scale and operational reliability.
It's practical, not experimental.
Exactly.
You know, this deep dive really clarifies that the modern operational bottleneck has squarely moved into the browser environment.
It's all in the browser now.
The logins, the portals, the dynamic interfaces, and all those legacy systems. Pendless claims to fix this by reading the page instantly, knowing exactly what to click, and handling the real-world complexities that cause other automation tools to break down.
From the brittle RPA scripts to the wandering AI agents.
It fixes the monotony with consistency.
And that takes us to our final thought for you to explore. If the future of work is genuinely about freeing humans for human-centric tasks, then the distinction between a flexible, open-ended assistant and a precise, repeatable, scalable robot is critical for your future investment decisions.
It's a key distinction.
So given this documented 480% increase in speed and near-perfect reliability, how will you apply this newfound precision to the specific multi-step browser workflows your team currently hates doing?
That's the question to take away.
That's it for this deep dive. Thank you for sharing your source material and allowing us to unpack the next generation of browser automation. We'll see you next time.